Cole, are you there?
I'm here. Can you hear me?
I can hear you and I can see you. Okay.
Good.
We're in good shape. Okay.
Yeah, so many of you may know me. I'm the engineering manager here. And if you call in for overrides during load control, I'm the guy that you get to talk to some of the time if you're not lucky enough to get Rose or Marty instead. So if not, feel free to give me a call if you have any questions. Make sure if you have questions during my presentation, you use the question and answer box to ask those so that I can try to ask them while we're going through the presentation here. So to start off, power factor, is this a new requirement? No, actually, since about 1972 at least, we were able to find in the records, capacitors have been required on all motors of 10 horsepower or larger. Recently, people have been using VFDs also to meet that requirement. So we waive the requirement for anyone that has a VFD since they're supposed to correct power factor as well. If you are not sure if you're getting a penalty applied or not, in your fall bill, you can check under the current service details section for each well. You see an example on your screen there. And the very bottom line item is the irrigation no capacitor charge. So this charge is going to be replaced with this new power factor requirement. Okay. So you see, we talked a little bit about the old way. Basically, you had to have a capacitor. If you don't have a capacitor there, you could pay the penalty. We really never verified that anybody's capacitor works, just that it was checked, just that it was a visual check that it was there or not, right? If you had a gray metal tin box and you wrote capacitor on the side and taped some wires to the side of the box, we might have counted that. Who knows? But now, thanks to our new AMI metering system, the new way is that we're going to use your actual data from your metering to calculate the power factor. So the penalty is now going to vary with the severity of the problem and the size of the system. And the size of the system is important because the larger your motor is, the more it affects power factor on our side of the meter. Some of you probably don't know what power factor is. I'm going to do my best to explain it. Power factor is a confusing topic a lot of times, and talking to engineers can be confusing. So this might be a tough combo, but if you have questions, like I said, get them in the chat and we'll make sure to answer them here. So the ratio of working power, that's your watts, or a lot of times we measure those in kilowatts, to the apparent power, which is volt amps or kilovolt amps. So work that gets things done versus work that wasn't useful, right? Many of you have probably seen a example that involves a beer mug, and while I enjoy a beer, it's just a little too early in the morning. So we're going to use a horse and a cart. I actually like this a lot better as an example. So everybody knows it takes work to pull a cart, right? Well, this cart happens to be on railroad tracks, and you're going to use your horse to pull it. So the horse, he doesn't like to walk on the railroad tracks. Now, ideally, for the horse to get the most bang for his buck, he wants to walk in front of the cart as close as possible. But he doesn't like walking on those rough railroad tracks, so he has to walk to the side of the tracks off at an angle there. So you can see the working power, the power that's actually pulling the cart forward, is what's going in the direction of the cart. Now, there's non-working power also, reactive power, right? If you've ever stood to the side and tried to pull something, you know it's harder to pull it than from the side than it is from straight ahead. So that non-working or reactive power in the case of an electric motor is VARs. Your total power, which is the combination of watts and VARs, and we can thank Mr. Pythagoras, who you probably haven't had to think about much since high school, for helping us calculate your total apparent power, which is volt amps. So you'll notice things that are measured in watts, your metering is measured in watts, things that are measured in volt amps. Your transformer is VA, so you'll hear us talk about how many kVA a transformer is, and you'll hear us talk about how many kW a demand charge is, or how many horsepower a demand charge is. kW and horsepower directly relate to each other. So
So Cole,
Yeah.
what I'm getting is you want your horse to walk closer to the tracks, but not exactly on the tracks, and that is better power factor.
Correct. Ideally, you'd have the horse in front of the cart as perfectly as possible, but we know that that's not possible, right? With an electric motor, there's too many variables there. It's too hard to get it perfect. So as we go through here, you'll see what's acceptable, and that's actually here on the next slide, right? So 100% is perfect power factor, but we're going to say anything that's better than 90% is good enough. Now, the reason that you don't want to necessarily be right at 100% is because it actually starts to go back down. You can't get to 100%. It's like a meter that's in the middle, right? If you go back this way, you go towards 90, but if you go back this way, you go towards 90. You want to keep the gauge straight up and down. So what happens if you're less than 90, right? If you're more than 90, nothing happens. That's acceptable. If you're less than 90, we're going to increase the calculated horsepower on your spring bill, and we're going to increase it in fixed charges based on that calculated horsepower. You're going to have to decide for yourself if the changes that it would take to fix this power factor justify the cost of the improvements, right? So if your system is above 90% without a capacitor, do you need to install one anyway? The answer is no. If you're above 90%, you're good enough. Whether that's because you have a VFD, because you have a incredibly efficient motor, for whatever reason, if you're above 90%, don't worry about it. You're not going to get an additional charge. So no longer will we be out looking for that capacitor, right? If you're above 90%, we don't care how you got there, just that you're there. So when are we going to start doing this? You guys have already seen some timelines probably come out in some of the publications, the irrigation newsletter, those kind of things. We printed power factor on your bill for the first time this fall. You'll notice we'll show you an example in a little bit here where you can find that on your bill. So this year we're giving you some time to consider what that charge may be for yourself and make changes if you see fit. We're going to print power factor on your bill again in the fall. So you can see if you did make a change this spring, how it affected your system. And then in 2022, we're going to start using that power factor to bill your new calculated demand. All right, so here's where you can find your power factor information, right? So if you've got a previous season's bill, particularly this fall's bill, look under the current service detail section there, and you'll see second from the bottom line there is power factor, right? This particular system has a power factor of 88.18%. They're awful close to 90. So that's going to be a real tough decision for them as to whether they need to improve or not. They may be okay with just paying the additional charge. It might be cheaper than having someone come put a capacitor on. Now, if you've got a new service, you're going to want to check your motor nameplate or with the motor manufacturer to get information about what your power factor might be while it's running at full load. Now, power factor fluctuates with the loads on the motor. So you'll want to make sure that we measure that at peak, right? If you're going to measure it yourself, and that your manufacturer gets that for you. Now, if you want to see how it's going to affect your horsepower on your bill, we have a handy tool we put on our website. So you can go to dawsonpower.com/calculator and use that to find your adjusted horsepower. And the example down below, this is a screenshot right from the calculator on the website. So you put in what your horsepower is off your bill or off your motor nameplate. You put in what your power factor is that either your manufacturer gave you or you found off of this fall's bill. And we're going to show you the adjusted horsepower right there. So for this particular person with a 30 horse motor and a 75% power factor, their adjusted horsepower is 36 horsepower. When we measure this, we're measuring it at your ultimate peak, right? So we measure your load all season long. We find when your motor pulled the highest amount of load that it had. And a lot of times that's when it also was running a swing arm if you had one, or also was going up a hill. Those kind of things affect peak, right? So you want to find what your motor is doing at the highest possible load it could be run at. And we'll take that time that the peak was measured, and then we'll look up and apply the power factor from that time. So that peak, it can occur at any time during the season. It's all going to depend on factors like I mentioned before, elevation of your field, and if you have swing arms or not, all those kind of things. So what can you do to fix this power factor, right? So capacitors are still king. They're still the main way power factor is corrected. So you can get a power factor correction capacitor. If you already have a capacitor, you're not getting that capacitor correction charge. So you know you have a capacitor there, but you look at your bill and you say, geez, I'm not above 90%. What's the deal? I have a capacitor. Why am I not above 90%? Well, maybe your capacitor was missized, right? Maybe it's too small, maybe it's much too large, and it already pushed you past 100% that far. Probably a better question is it still working? Capacitors do not last forever. So there's a good chance that some of these older capacitors that have been out there for a long time just aren't working. All right, well, let's say you've got a variable frequency drive, right? Those don't need capacitors. Why am I below 90% if I have a variable frequency drive? Well, the most likely culprit is that it's not programmed correctly to fix the power factor. So you're going to want to call the manufacturer of the variable frequency drive or the installer to get that corrected. Now, you don't have to correct your power factor. If you're okay paying a little extra because your power factor is below 90%, that's fine. Dawson Power will take that additional charge and we will use it to buy power factor correction equipment on our side of the meter. So here's a couple examples, right? The guy on the left here has a 98 horsepower motor with a right about 60% power factor. So he's clocking in the 148 horsepower roughly. You can see the two charges that he gets there before and after the adjustment. So this is an annual difference of $1,638. That's probably going to be worth it to put a new capacitor on and get that corrected, right? Now, let's say you're just a little 23 horse motor with about an 83% power factor. Well, that bumps you all the way from 23 to nearly 25. So your difference before and after the adjustment is only $62 a year. So maybe this one, you don't care if you have one on this year. Maybe you want to wait and fix it the following year. Maybe $62 is just not enough for you to worry about in an entire season. So if you chose not to correct that, that's fine. And actually, if the person on the left decided that they didn't want to correct that and are okay with paying that difference, that's fine as well. I called it a penalty earlier, but it's just a charge we're assessing, right? You can either fix this power factor on your end or we'll fix it on our end. So what causes poor power factor? Anything that is an inductive load causes your power factor to decrease, right? So some common examples, obviously electric motors is the big one. That is the number one cause of a reduced power factor. Also, things that can affect power factor are like customer transformers. If you've got a big customer transformer, say, that's stepping down from 480 volts to 240 volts for a old grain dryer service or a building you happen to have with your irrigation well or something. Or maybe you plug a tractor in there in the winter. Those kind of things can increase your power factor also. There's probably not much of this on customer service, and if so, it's probably not a major contributor to your power factor compared to your motor, but high intensity discharge lighting, so those are like yard lights, the high pressure sodium or old mercury vapor ones especially. But basically anything that needs an electromagnetic charge to operate is going to reduce power factor. If you've got a correction device that's over compensating, so it's putting you over 100%, that also could potentially be affecting your power factor. Basically, if your capacitor is way too large for the motor it's paired with. Okay, so if you've got a capacitor and it's not working, and you think to yourself, well, has this thing failed? It's very likely if it's an older capacitor. The most common reason of way they fail is just short circuiting, because over time, older capacitors dry up, over transients, over voltage and transients like lightning can reduce capacitor life, or if you have poor grounding at the panel when there's surges. High temperature can reduce capacitor life. So obviously, welcome to Nebraska. It gets a little warm in the summer, so those capacitors probably are experiencing some high temperatures, which would reduce their life. If you go to your capacitor and you open the little container that it comes in, you'll see in the picture here, the yellow arrow points at the box, which holds the capacitor on this particular service. And you see that the capacitor is bulging or it has an open pressure vent. That's a good indicator that that capacitor has failed and it's no longer doing its job. When your capacitor fails, your motor is still going to run. The capacitor will not stop your motor from running. So just because your capacitor's failed doesn't mean that you're going to be able to tell by a motor that won't start. So let's say you've got a VFD and it's below 90%. So what happened there? Or maybe your VFD's not working at all, not even letting your well start up. So one thing could be that it's not programmed properly. We've seen a lot of VFDs that are left at factory settings, and they have particularly high settings for their low voltage requirements, which has caused some issues for customers, especially these last couple summers. Over voltage, such as lightning, can cause this. High temperatures by maybe a fan failure in your VFD, and basically anything that could damage a motor or computer. VFDs are just computers that are sitting out there tied to your motor.
All right. I think we'll move on to protecting our equipment. For this one, we have Bobby Johnson with us.
Good morning. Basically, protecting your equipment is just an additional insurance policy. Some of the most common issues with the VFDs or just your control panel out in the field is somewhat preventable from a protection aspect. Things are going to happen on the power lines out beyond our control, beyond your control. As far as the motors themselves go, something called a motor saver, which is a trademark name of a piece of equipment that will protect against under voltage, phase loss, and a variety of other type issues. Not a real costly investment. As you see, we've talked to some local electricians, and roughly $200 to $300 will put this piece of protection. A lot cheaper than replacing a multi-$1,000 motor or control panel. Another type of failure that we see out in rural America, of course, is transients. To protect from those type of incidents is a surge suppressor. This is typically installed right at the motor, protect from lightning damage, protect from some other failure within the actual irrigation system itself. Another fairly reasonably priced insurance policy, if you will. So a couple of different ways. If you don't have this type of protection on your systems, highly recommend talking with your electrician or your irrigation equipment provider to possibly add this type of equipment. Okay, so many VFDs will have protection built into those, but some of the more common pieces of equipment that would protect that VFD, as Cole said, that's basically just a computer sitting out in the middle of the field. So add a surge suppressor. Your local electricians will have access to this device. It's a very common device. It's also used in your homes quite often. So either talk to an electrical distributor, but go directly to an electrician or whoever does work on your equipment. They'll be able to help you with that.